Okay, so today we're going to look at the FAGOR BiSS-C with sine cosine or without sine cosine. This one is without sine cosine, but we'll take a look at it. So I've got this FAGOR encoder. So the strip is in here and the read head is here. This would be the spec. It's 0.01 micron or 10 nanometers. Accuracy plus or minus 5 micrometers per meter. So that's good high resolution, good accuracy over the distance. It's a 20 micron incremental track, so that's good for doing a sine cosine on. And most of the drives that have the BiSS can do the line delay compensation. Some of the standard drives, not really. So the cable length is limited at 5 megahertz to half a meter, but with the lower frequencies, we can get longer distance cable lengths. Doesn't seem to be a problem at whatever frequency for the BiSS from the plus drives with the compensation delay and various numbers to order, and there's mounting and I guess position limit switches that can be added to it, but it's absolute, so just turn it on and it can automatically be honed. So the number of bits is 32 bits. The frequencies is, of course, can be megahertz. BiSS-C standard, 5 volts, 250 milliamps. Those are some of the standard specy things in the sheet for the encoder. It has a lot of mechanical mounting information, so that's good to pay attention to, and some diagrams for wiring. Take a quick peek at the setup here. So here's the linear strip and the read head. I'm going to move the linear strip, but we can see the Copley BEL connected to the feedback device. I'll show you the wiring in a minute, but I'm monitoring the data. So we put clock out and then we get data back. So every 250 microseconds, the drive will clock out the data in a position mode. In a current mode, at 62.5 microseconds. And so these pulses would be at the megahertz. That's a 4 megahertz signal there. And you can see the data coming back. And as I move the encoder, you can kind of watch the data count. And so that's the count for the absolute position as we move from one end to the other. So for the wiring diagram, I use this sheet here. I wired up the sine cosine for this one on A naught, B naught. That's the plus or 1 volt peak to peak, or plus or minus 500 millivolt sine cosine clock and data, plus 5. I also wire the sense up to the plus 5. This doubles my wires, so reduces the IR drop over a distance. And so these are the color of the wires that were on the flying lead. So one end had a connector for the encoder with a pin out, and the other end was flying lead. And these are the colors. No real problems with the colors. They were pretty obvious. The shield, I hooked up the outer braid to pin 1, and I just hooked up the inner shield to the frame ground too. So you can connect the inner shield to the signal ground for better signal to noise ratio, but it's clocking data and it's pretty good. Differential transmission and proper grounding and shielding should be fine. Just don't connect the feedback case of the motor to the shield. So if the encoder is on the motor, just make sure there's either some isolation or non-contact or good grounding for the motor case. So we'll take a quick peek at the configuration. So I've got CME2 connected. I'm going to say it's like a DC brush motor with a linear encoder at the end of a ball screw or something, but I can't pick it. It lets me pick voice coil, so I use that instead. So no feedback on the motor, BiSS on the load, primary feedback, sine cosine would come in on this same input too. So we could say, if it's a linear motor, you could say BiSS on the motor and sine cosine on the load, and then close the position on the sine cosine. You get the absolute on power up. As far as the configuration, you can see 32 bits, and it's a 0.01 micrometer BiSS-C. The advanced settings, well, you can see that I've got a fault here for the streaming bit, the error, and the warning. So I'm going to invert active low and see if we can get rid of that feedback fault here. Okay, so let's see. So the feedback fault is latched, and if the fault goes away, I can clear the fault and encoder refresh. All right, so that did not do it. Let's go through that again. So advanced settings, uncheck the box. Okay, and let's take a look at encoder status. Now that seems to be cleared. I can clear the fault. Okay, and let's, so that saved a flash. I'm going to reset the drive and see how it comes up. All right, so clear fault, refresh. All right, so the fault's cleared, and I've got some absolute position. I'm going to the homing. Okay, I haven't done any homing yet, so I'm going to reset the drive and see what the position is on power up. So this would be part of like a homing process. Okay, so I don't want it to be in this position. I want that to be 0. And I want that to be a higher number. Oh, following error. Oh, well, let's just turn that off because that's really annoying. I don't have a motor here. Okay, clear fault. Look at the homing. If you did some homing, you're going to have to clear it out. Set current position as home. Okay, save it and reset the drive. No. So I'm resetting the drive. It's connecting. On power up, homing has not been executed. And we can see the absolute position is displayed on the control panel. So we're going to use that to do the absolute immediate home. So absolute active immediate home, I'm using it to close the position loop. I put in the distance, 156.97926. So I want this position that I'm in to be the 0 position. It's all the way at one end. And I'm going to execute the homing, and now it's the 0 position, and I save that. So now this is like calibrated for the feedback device. I'll move it to the middle. I'm at 100 millimeters from the 0 position. If I reset the drive, it'll come up, ask the encoder, what's your position? It'll say, minus 156 at the 0 position, plus 100 millimeters. It still would say minus like 56 millimeters, but I've calibrated it so that it adds an offset immediately on power up or reset. So the homing is done. Just turn the power on and you're homed. Okay, so it's been calibrated. If you take it off and move things around or reconnect different drives, of course, you'll have to calibrate the system. So just, repeat the process. So set current position as home, So it's like, just make sure it works. Okay. Okay, so that does work. I'm going to save it to flash, and I'm going to reset the drive. And you'll see it'll come up after being reset, and it's not moving or anything, but the homing has not been done. Okay, so I'm at the minus 51 millimeters, and I want 0 to be down here. All right, that's minus. I'm just going through the process again. So let's configure the homing. So 156, and then home it. You can see it works, and then you can save it. Don't forget to save it. Exit, and then when you reset the drive, it'll come back up, and it's in the position that I want to be 0, program it to be 0, minus the rounding error there. So there, that's the 0 position. A little bit off of the hard stop. That's kind of nice. I like not being on the hard stop anyway. So, and then you from one end to the other, and this is being displayed in millimeters on the control panel, but the drive units are counts, and we can see on the feedback again, we have 0.01 microns of resolution, and the box is not checked, and it seems to be working. All right, so that's a little bit confusing because before I had to check the box, but I'll check with engineering on that. But it works, and generally, yeah, I'm using 5 firmware, but 4.60 should be fine, 4.36. And we have applications using the FAGOR BiSS-C. And of course, the sine cosine is perfectly fine to get and add, although you don't need it. We can interpolate it, but we don't need to use it. Although if you have it, wire it up. If there's some cabling, grounding, shielding problem, you'll probably have a CRC fault, and we'll fix the cabling, grounding, shielding problem, and your CRC fault will go away. But you can use sine cosine just to move, like say a linear motor or something, just for a test. Okay, so if there's any time left, we'll just take a quick breeze through the brochure. Yeah, really long travel, many meters, nice design, waves of light, I like that. Different drives, sort of 2 feedback sensors for incremental and absolute. That's kind of cool. Good mechanical design here. The one I have is so easy. I don't have to worry about the gap or the mounting. Lots of different connector styles. Sine cosine. Oh, voltage over distance. So you'll get a voltage drop over a long distance. But it's 250 milliamps, and it looks like a, I don't know, good gauge wire. And there's the various, there's the limit switch markers, different connectors, and worldwide. Great. Well, thanks for watching.